This video will look at perpendicular bisectors. In locating points and midpoints, we learned that a segment bisector is any segment, line, or plane that intersects a segment at its midpoint. So that's the key there. It's going to intersect a segment at its midpoint. If a bisector is also perpendicular, so if it's also perpendicular to the segment, it's called a perpendicular bisector since it's perpendicular. A locus is a set of points that satisfies a particular condition. The perpendicular bisector of a segment is the locus of points, or all the points in a plane equidistant. So equidistant means equal distance from the endpoints of the segment. This leads to the following theorems. So equidistant from the endpoints of the segment would mean that if you took a point here, then it would be the same distance to both endpoints of the segment. This gives us the following theorems. The perpendicular bisector theorem tells us that if a point is on the perpendicular bisector, so if CD is our perpendicular bisector, then C is a point on the perpendicular bisector. That point is going to be equidistant from the endpoints, so from equidistant from A and B. So we know that AC and BC are going to be equal to each other. Conversely, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So in this case, we know that AE and BE are equal to each other. So we can say that this point, E, lies on the perpendicular bisector of AB. Let's take a look at a few examples. Find each measure. So AB, let's figure out what this AB is here. So we can see that CA is a perpendicular bisector of BD. So CA is a perpendicular bisector of BD, and we see that AD equals 4.1, and since all the points on the perpendicular bisector must be equidistant from the endpoints, we can say that BA also equals 4.1, or AB 4.1. The next one, we see that WX and WZ both equal 9. So by the converse of perpendicular bisector theorem, we can say that XY is our perpendicular bisector to the segment WZ, and by definition of a segment bisector, this side is going to equal this side. So WY is going to equal 3. Lastly, we have another perpendicular bisector, SR, through the segment QT. So we know that these sides are going to be equal to each other. 2x plus 3 is going to equal 4x minus 7. So let's write an equation to set those equal to each other. 2x plus 3 equals 4x minus 7. Let's subtract 2x from both sides. We get 3 equals 2x minus 7. Let's add 7 to both sides. We get 10 equals 2x divided by 2 on both sides, and we get x equals 5. And it's asking us for RT. So RT, let's plug back in 5 for x here. We get 4 times 5 minus 7. So 4 times 5 is 20 minus 7 equals 13. So our RT is going to be 13. And just to double check, let's also plug in 5 for this x, because we know that it's they're going to be equidistant, so this one should equal 13 as well. 2 times 5 plus 3. 2 times 5 is 10, plus 3 equals 13. So that checks out.